of experiments is more efficient. It will save you time in the future. Maybe your startup, probably the most powerful feature. Hey everyone. So in my first video I talked a little bit about why I think that the traditional one factor at a time experimental design is outdated. And I said that there are better methods to plan and execute and analyze experiments. And the one method I actually think should be standard for scientists and engineers is design of experiments. Imagine you're an engineer at a major automobile company and your task is to cut down the costs that are associated with the coatings process of a car. You come up with 3 variables that could be changed: the coating thickness, the temperature of the ovens, and the process time. You want to reduce the coating thickness, that saves money. You want to reduce the temperature and you want to reduce the process time, because all this will save you resources in the end. But the problem is, if you reduce the coating thickness too much, then the coating will lose some of its properties and the customer will not be happy with that. Same with the temperature, and also the process time will demand how long the car stays in the oven, so that also has an influence on the properties of the paint. If you would decide for a one factor at a time approach, you would start selecting a starting point for each factor and then vary these factors individually and find their individual optimums, which are then the starting point for the next row of experiments. If you do a DoE, you would decide on a design space. You would decide on a temperature range that you think is relevant, a range for the coating thickness and also a range for the process time. And then you would actually only test the edges of that design space. And usually with the DoE, you would also test the center point. And deciding on that design space, that's based on experience, or there you could actually stick to the one factor at a time method to get some idea about what's possible and what's not possible. For example, it doesn't make sense to test the coating thickness from 0 to 100. I mean, no coating, that's not an option. If you, like for this specific example, if you compare the number of experiments here with the traditional one factor at a time method, with the traditional one factor at a time method, you conducted 9 experiments. And with the design of experiment method, you also conducted 9 experiments, but you covered a much wider design space. So you get a lot more information with the same or even less experiments. And that's why design of experiments is more efficient, especially more efficient the more and more variables you include into your design, into your study. Imagine you're planning an experiment with not only 3 variables, but maybe 15 variables. That's really complicated. If you do that maybe in an Excel spreadsheet or just by hand, that's almost impossible to do. But with design of experiments, it's just a couple of clicks in your DoE software. And there are many great DoE softwares out there, and they make it really easy to apply DoE. A design like this here is called a full factorial design. There are also fractional designs, because the problem with full factorial designs is that the more variables you get, the more experiments you have to do, and that explodes quite quickly. So at some point it really makes sense, especially for initial screenings, to stick to a fractional design that provides you less information, but usually you don't need all that information in the beginning at least. Probably the most powerful feature of design of experiments is its predictive capabilities. What that actually means is that when you concluded your experiments, you will have a statistical model that you can use to predict the properties also for values that you did not include into your testing. So that could be really powerful for this specific example, because let's say at the moment you do not really have a high demand in cars. Maybe you're a startup, but in 6 months from now, your demand increases. More and more people want to buy your car. But that also changes the whole study that you did, because your parameters change. But with DoE, you go to your computer, take that model that you have from the DoE you conducted, you type in the new process time, and you'll get a prediction of which parameters for temperature and coating thickness you should use for that new process time. Design of experiments is not complicated at all. It's similar to driving a car. When you drive a car, you don't have to be a mechanic, but you need to learn some basic rules, and the same applies for DoE. If you learn some basic set of rules, you can plan and design amazing experiments that will give so much more value to whatever you do in your daily life. So don't forget to subscribe if you want to get your DoE driver's license. See you in my next video. Bye.